Hey everyone, today we're going to solve this LeetCode problem, that is 2215, find the difference of two arrays. It's a easy level problem and it has a lot of likes, 1.3k likes and only 55 dislikes. And the best part is that it was asked in Google interview one time. From this extension, Big O extension. The data is that it was asked in Google for one time. Now this is a good problem actually because there are some minor mistakes which can be made if you haven't like understood the problem correctly, or even if you have understood the problem, there can be some silly mistakes that people can make, that students can make. So which is why this is a good problem and it has a lot of likes. So let's start. So we are given zero indexed integer array nums1 and nums2. We need to return a list of answer, that is answer of size 2, where the first element is a list of distinct integers in nums1 which are not present in nums2, and the second element of the answer list will be distinct integer which is present in nums2, which are in nums2 but are not present in nums1. Which means if you have this array like so this is nums1 and that is 1, 2 and 3, and then you have nums2 which is 2, 4 and 6, right? So the brute force approach to solve this will be that for every iteration, for example, this is our answer that we need to make, and there are two elements, right? The first one is a list and the second one is also a list. Now the first one says that we need to check if every element in the nums1 is present in nums2 or not, and if it is not present, then it will be stored in the first element of the list of answer list. So one is so let's say 1. Now we are currently on 1. Is 1 present in nums2? No, it is not. So 1 will be stored. Is 2 present in nums2? Yes, it is. So 2 will not be stored. 3 present in nums2? No, it is not. So 3 will also be stored. So right now we have 1 and 3 in the first element of the answer. Now we'll do the same thing but in an inverse fashion for nums2. 2. Is 2 stored in nums1? Yes, it is. So we are not going to store it. 4 is present in nums1? It is not. So 4 will be stored. Is 6 present in nums1? 6 is also not present. So 6 will also be stored. So the answer will be 1, 3, 4, 6, and this is the answer. Right? Now let's look at some another test case. This is a good test case because it has cleared a lot of my doubts. Now, for example, in this case, you have nums1 that is equal to 1, 2, 3, 3, and nums2 that is equal to 1, 1, 2, 2. Okay. Now we do the same thing. So this is the first array and this is the second list and this is the whole answer list. Now 1, is 1 present in this? Yes, it is present. So we are not going to store it. Is 2 present in this? Yes, it is present in nums2. We are not going to store it. Is 3 present in nums2? It is not. So we are going to store 3. Is 3, well, 3 is already done, right? 3 is already concluded and 3 is provided in the set, so we are not going to store it. This is another concept which I think is not, yeah, it is actually given. So you're said that distinct integers, right? So this list element will have only distinct integers, and if it is distinct, then this 3, if we process this 3 again, then we don't have 3 nums2, right? So we'll be storing it, but now we need the condition to be distinct, so we are not going to storing it. So we are not going to store it into the first element of the answer list. Now the same process, 1 is present, so we are not going to, 1 is also present, 2 is also present, 2 is also present, so we're not going to store anything. So the answer will be 3, empty list, and this is the answer, right? So let's solve this question. Now let's write. By the way, the brute force approach is, I think you all can see that for every if there are n elements, if there are n elements, and in this case we have m elements, in the brute force approach precisely, we are going to have the time complexity of n into m plus of m into n. And the reason is very simple, because in the first iteration we are doing m iterations, because we are linearly checking for every element, is it if it is present in the nums2 or not. And for every element we will be doing, for yeah, for every element we will be doing m, like the length of the nums2 array, and that is m. And how many elements are there in total? That is n elements. So it will be n into m, and for the second iteration we'll be doing m into n, because for every m element we are doing n checks, right? So this is the time complexity for brute force. And space complexity will be, now auxiliary space is not, is a constant, but the space complexity in general will be order of uh, will be actually order of max of m into n. And the reason is because we are storing in distinct elements, and in worst case where you have distinct elements, right, and every element in n is not present in m, or vice versa, so the maximum size of m or n could be because it's an upper bound, so it could be the space complexity. But in the auxiliary space, it's constant, because we are not, I mean, yeah, it's constant in brute force, it's constant, but in the optimized way it will not be constant. So let's start with the optimized way. So the optimized way to solve this problem will be, let me erase these. Not actually this one. Sorry. So yeah, so the optimized way is to store a set. Store these elements in a set. So for this case, we are going to create a set for it, and the set will be 1, 2, and 3, right? For this case as well, the set will be 1 and 2. Fine. Now, when we are traversing, rather than making these comparisons, that for every an element we are making m comparisons, no, we are not going to do it. But we'll do it for every element. We ask the set, do you have 1 in yourself? Yes, I do. The set will say I will do, and it will constant search, right? Because the, yeah, because the numbers, the range, the length of the numbers, and range of the value of the numbers is not high, so it will be almost constant. And in the second element as well, it will ask for the, and for third, now for the this third element, that is 3, it will ask the set, do you have 3, and it is not present. So this way, for every, first of all, we will do n elements, and we multiply it by 1, because we are only doing the lookup in constant time. So that's basically n. And for every l elements, we are doing lookup is 1 constant. So this is the time complexity for optimized way by using Hashset. And the space complexity, because we are using Hashset, the space complexity will be max of uh yeah, it will be actually not max of it. It will be n plus m again. And the reason is because yeah, it's actually it's the worst case where you have all the distinct elements in in nums1, and all the distinct elements in nums2. In that case, it will be order of n plus m. So let's write the code for it. So first of all, we need an ordered set 1 for nums1, and we will also have set 2 for nums2, and we will also use set for our answer 1 and answer 2, and we are also going to have a vector or vector int for our answer, and that is it will have two values, right, because it is given that of size 2. Now the first thing is we need to make a check for every element that is present in nums1, if it is present in nums2 or not. So that will be nums1 if set2 dot find, because we are finding in nums2, right, so we are going to use set2 dot find is equal to set2 dot end. In that case, answer1 dot insert num, and we are going to repeat the same process for nums2. Yes. Now when we are done with this, now we need to have this, answers into our array. So what we into our array, that is answer elements, right? So for int num answer 1 answer 0 dot pushback num, and we're going to repeat the process again for the second element from the answer 2 set, and then we are going to return the answer vector. Okay, so there's an issue. Let's see. Nums2. Okay, it has to be nums2, and it has to be nums1. Okay, its test cases are running fine. Let's try submitting it. Okay, it is submitted and it is not performing. Okay. Yeah, I'm using the exact same approach um as there, so I don't know what's the issue. Wait, max of but I'm using two sets. Mm, okay, one method. Right, got. So yeah, makes sense. I mean, I'm using the same approach, the time complexity is same, so I think this is a good solution. If you want to check out the source code, it will be in the description. If you want to try the problem yourself, the link will be also in the description. And if you have any doubt, connect me on LinkedIn, or you can also ask in the comment section. Thanks for watching and have a good day.